Okay, so today we're going to talk about the cosine law. We have three goals for this video. The first one is to determine when to use the cosine law, because we already have the sine law, so we have to decide when to use which. The second is we're going to develop the formula for the cosine law using our basic trig ratios. And then we're going to show you, and then lastly we'll show you how to use the formula. And so we're going to start with just basically what the cosine law is. So the cosine law is the formula describes the relationship between the cosine of an angle and the lengths of three sides of a triangle. So this is the key to this, is that you're going to be using the three sides of a triangle that is not a right triangle and one angle. So in this case, you would use the cosine law to find x. You have two sides and one contained angle. The sine law wouldn't work in this case because you don't have enough angles and you don't have enough information. So so that's our first thing. When will we use it? When we're trying to use the three lengths of a side of a triangle and an angle. Okay, so we're either given the three lengths and we find the angle, or we're trying to find one of the lengths given an angle. Now, here's how we develop it using our basic trig ratios. So I've just drawn a basic triangle and labeled it A, B, C. And then, of course, the same way we did before, across from the angle, the big letter is the small version of the same letter. Okay? And I drew an altitude in, which is the height of h. Now down here you'll see that this entire side is A. So if I label this as x, then this other little piece here is whatever's left over. So it's A minus x. Now if I'm looking at the angle C, so I'm looking for cos of C. So there's the angle I'm looking at. Cos is adjacent over hypotenuse, so it's x over b. Now I can rewrite this so that it's x equals, and that would be b times cos c. Okay, so all I've done is multiplied by b on both sides. That eliminates that, and then I write it like that. We'll need this in a minute, so we rewrote it as x. We also know that b equals h squared plus x squared if we use the Pythagorean theorem. So if I look back to my triangle here, I'm looking at this triangle, so b squared equals x squared plus h squared, right? Now, if I look at the other side of the triangle, I can use the Pythagorean theorem again, and I can identify this triangle. So in this case, it's h squared equals c squared equals h squared plus a minus x squared. Now this is the only tricky part of this, is remembering how to FOIL. So when we FOIL, this actually means this over here. It means this written out twice. So in order to FOIL, it's first, outside, inside, last. That's how we do it. So the first is a times a, which is a squared. And then it's the outside 2, which is minus ax. Inside 2, again, minus ax. And the last 2 is negative x times negative x, which is positive x squared. So if I simplify that, putting these two together, because they're like terms, I get a squared minus 2ax plus x squared. Okay, so that's just the FOIL. So I'm going to rewrite this with this new term in there. So I get c squared equals h squared plus a squared minus 2ax plus x squared. Now, let's rearrange this so that I use some of these terms up here, these two things. So I want to get rid of the x, and I want to get rid of the h, and I want to get rid of this x. I want to get rid of the x's altogether, so there's no more x's and no more h's in my formula. I can rewrite this, so I can move this x to be next to the h. So if I rewrite it, it would be c squared equals h squared plus x squared plus a squared minus 2ax. Now I can replace this h and x squared with b from up here. So if this formula, b squared equals h squared plus x squared, that means that this whole thing is just b. Okay, so that gives me c squared equals b squared plus a squared minus 2ax. I still have this x here I want to get rid of. So that's when I'm going to use this cos term up here. So I'm just going to move it down here so that you can see it. So from up there we decided that x equals cos b cos c. So I'm going to replace the x there with that. So I get c squared equals b squared plus a squared minus 2a, and then I'm going to substitute in that b cos c. And there is the cosine formula. That is one way of writing it. C squared equals a squared plus b squared. You can write it in either order. A squared plus b squared minus 2ab cos c. That is the formula for the cosine law. Now if you flip over the page, when I flip over the page, I've written it several times. So a squared equals b squared plus c squared times 2bc cos a. That's one way. The other way, b squared equals a squared plus c squared minus 2ac cos b. C squared, this is the one we had on the last page. C squared equals a squared plus b squared minus 2ab cos c. All of these are just the same formula rewritten differently. And I want you to just look at it and what is a pattern that you notice about this formula. What I notice, so if you pause it and just look yourself, and then I'll tell you what I notice. This is B and this is B. A and C and A and C. So that's the same throughout. So A, the angle A. B and C, B and C. C, angle C. Okay, so remember that the capital letters mean the angle. Those are the angles. And the small letters are the lengths of the sides. So here we're going to apply the formula for the first time. So here I've got triangle ABC has sides A, B, and angle C. Now I know that angle C is 20 degrees. That means it's going to have to be either here or here. So one of those is going to have to be the C point. It doesn't really matter which one you choose. So we'll try there, and then we'll label this one A, and we'll say this is B. Okay? Now that doesn't work because look at the length of B, it's 5. So let's switch those two places. This is just, when you're drawing it out, you're just going to be giving the information and you have to draw it. So let's take this one as, let's take this one as A. Let's take this one as A, and then this one is B, and then C. So this is 20 degrees. Let me write that so that's a little clearer. So we'll say this is 20 degrees. B is 5. A, which is across from here, is 11. And the angle C is 20. So I've written all the information that I have in there. Now I need to use one of these formulas up here for this. You have to find the one that's appropriate. We're trying to find this side over here, which is the X. Now notice it's across from the C, so we're trying to find the C term, the C side. So we're going to use the bottom formula right here. So we're going to say C squared equals A squared plus B squared minus 2AB times cos of C. Now I'm going to pause the video and let you guys try this, and I'm going to try it as well. Okay, we're going to substitute in the values. So C, I don't know what C is, but I do know what A is, and it's 11 squared plus 5 squared minus 2, and then it's 11 times 5 cos, and the angle C is 20 degrees. So now I'm going to get out my calculator, and I'm just going to enter all that into my calculator, and I get C squared. So again, I'm going to pause the video. Okay, so I did these two and I got 146 and I multiplied that, I got 110. Now I'm just going to enter the rest of that into my calculator. So I go 110 times cos 20, making sure my calculator's in degrees, and I get c squared equals 146 minus 103.366. I subtract those two, and that gives me 40, c squared equals 42.634. Now, in order to find c, I find the square root. So I take the square root of that number. That's the cube root. 42.63. 42.634, and I get 6.5 centimeters. So the value of C is 6.5 centimeters. So this is just strictly an application. This is just taking the right formula, finding the right formula, and just plugging in the numbers. It's actually the hard part is setting it up. This part will be the hard part, setting it up and figuring that part out. Now we're going to use the same formula to find an angle. So it's a little bit different, but the same idea. So a triangular brace has a side lengths of 14, 18, and 22. So 22 is the longest side. I'm going to write it right here. And 18 and 14, this one kind of looks a little longer than the other one, so I'm going to write those ones in. So I have three sides. Notice that as soon as I have three sides, I know I'm going to be using the cosine law, no matter what. So then it says determine the angle opposite from the 18. So let's see, opposite to the 18 is right here. So this is the angle that I need to find. We're going to call that C. We'll call the other two sides A and B. And it doesn't matter, again, what letters you use. You could use your initials, whatever makes sense to you. Okay, but because we're trying to find the angle C, we're going to use the formula that has C squared in it. A squared plus B squared minus 2AB, this is A, cos C. And the reason we use that formula is because this has the angle C in it, and none of the other two formulas do. So let's substitute all the values we know into this. So we do actually know C in this case. It's 18 squared. And we know A is 22. And we know B is 14 squared minus 2. Again, we know A, it is 22, and B should be 22. And B is 14. We don't know this C over here. So what we're going to have to do is rearrange this formula so we can solve for that. So let's expand the formula. So I'm going to pause the video so that I can do that and you guys can do that. Okay, so I just squared all those numbers. I got 18 squared, 22 squared, 14 squared, and then I went to 22 times 14, and I got all this. Now, I've got to remember order of operations, which means I have to move all of these over to the other side first. This is multiplication in between here, so that's going to be the last thing I do. Okay, so let's move these over by subtracting them. So I get 324 minus 484 minus 196, and that gives me, so it's negative 356 when I subtract these two over there. Okay, and then that equals negative 616 cos C. Now this is, again, I said this was multiplication, so the opposite of multiplication, division. So I divide by 616, negative. And I do the same thing on this side, so negative 616. So 356 divided by 616 is positive, because they're both negative, 0.577922, etc. And that equals cos C. And when I'm trying to look for an angle, when I'm given this, I have to do the negative one, because the opposite of cos is the negative one. So I'm going to go shift cos to the negative 1, and then I'm going to have my number, which is 0.577922, etc. And that gives me C, the angle C. And that angle is 54 0.695 degrees, which if we rounded it to the nearest degree would be 55 degrees. Okay, so C is 55 degrees. And that's how you do it for the angles and for the length of a side. So in the next example, I have two more examples to show you. Okay, so here's the final two examples. The first one is to find this missing side here. And so we'll label that as X. And I'm going to make this A, B, C. Your call how you want to do it. So this across from here is the little c. And then these are the opposite two sides. So this is B and this is A. So I've taken all the information that I have and I've substituted it into the formula. Okay, so c squared equals a squared plus b squared minus 2 times a, b, cos of the angle. Now, I just simply calculate that out and I end up with c squared equals, and it's 352 minus, and then it's 952 cos 43. So I've done two steps here. I've done these two and added them together, and then I multiplied these together, gave that. So now I have c squared equals, and so I calculate this out, subtracted from that, and I end up with 655.75. Now in order to find c, I simply take the square root, so c equals 25.6 centimeters. Okay, so that's that. So the first step was to substitute the equation and then solve just by simplifying it as we go down. Now here, up here, again, number 2, we're trying to find the angle now. So this is just the same question, but using the formula to find the angle. So we're trying to find this angle here, n, and I'm given 3 sides. So I know when I'm given 3 sides, I need to use the cosine law. So I looked at this and I said, okay, if this is the angle that I'm trying to find, this will be little n, and this is L, and this is M. So I'm going to rewrite the formula so that it has L, M, and N in it. So it's n squared equals L squared plus M squared minus 2 times L M cos capital N. Okay? Now again, I'm going to fill in all the information that I know. So this gives me, when I fill it in, I get 6.9 squared equals 2.7 squared plus 5.1 squared minus 2 times 2.7 times 5.1 cos n. Okay? Again, you're just checking your answers on here, so if mine's a little bit messy, I'm just going to leave it. And so then I calculated out all of these squareds, and that gave me 47.61 equals 7.29 plus 26.01 minus 21.42 cos n. And I solved this. I subtracted both of these from this side and then divided by 21.4, and that ended up with cos n equals negative 0.66867. And then I did the -1 tan, the cos -1, and I got the angle n to be 131.9 degrees. Or 132 degrees. Now you have to go back and look up here, and you can see that it's got to be bigger than 90, so that's about the right angle, 132. Okay, that's it.